Stop watching the price for 1 second, because the next move in silver isn't starting on Wall Street, it's starting inside a pipeline. As of today, January 24th, 2026, Germany's gas storage is hovering at 41.8%. That sounds survivable. But in industry, a little above 40 is not comfort. It's a countdown. Germany entered the heating season around 76%. By the start of 2026, it had already slid into the 50s. And now the gauge is sitting between 39.7% and 41.5% depending on the facility cluster, according to reporting that cites the EU storage dashboards. And here's the part most people miss. Gas storage isn't a savings account. It's a pressure system. When storage is full, it can push gas out fast. When storage empties, deliverability drops. The same facility that can feed an industrial city in November can choke in January, not because the gas is gone, but because the system can't pull it out at the same rate when pressure falls. This is not a conspiracy. It's physics. Storage facilities have ratchets. Withdrawal capability declines as inventories decline. The tank isn't just smaller, it becomes weaker. And if you're wondering where that number comes from, mainstream energy reporting in Germany has been pointing directly to the AGSI storage dashboards and the INES storage monitoring. The headline is simple. Germany started the heating season around 76%, entered 2026 around 57%, and now sits slightly above 40%. That's the slope that matters, not the exact decimal. And pressure is everything. Pressure is the invisible muscle that keeps gas moving through pipes, keeps flow stable, keeps grids balanced when demand spikes at 6 p.m. and the wind dies at 6:05. When pressure falls, operators don't wait for catastrophe. They preempt it. They reduce risk. They cut what can be cut. They keep households warm. This winter has been weird. Mild stretches slowed withdrawals, but storage still sits at a historically low level for this time of year. And every time Europe hits a windless, sunless cold snap, the famous Dunkelflaut, the grid leans harder on gas to keep the lights stable. No wind, no solar, you burn gas. That's the backup generator for a continent. So why am I calling 41% a redline? Because in Germany, the gas emergency plan is not theoretical. The framework is active. The regulator publishes status assessments, and the country's emergency plan outlines 3 steps: early warning, alert, and emergency. In emergency, the state allocates fuel, and industry gets curtailed first to protect households and critical institutions. That's not rumor. That's the design. Think about what that means in plain language. If Berlin has to choose between a hospital and a refinery, it's not a debate. Protected customers come first. Everything else becomes interruptible. And interruptible is a polite word for you are the first sacrifice when the math turns ugly. And I need to be honest with you. 41% redline is not an official legal stage written in stone. It's an operational red flag because planners know how quickly things can accelerate once you lose flexibility. The official legal stages are the emergency plan stages, but markets move before laws do. Markets move when operators whisper, "We might have to cut." People imagine rationing like a movie. Sirens, speeches, the lights going out. In reality, it starts with contracts. It starts with utilities asking certain users to reduce consumption. It starts with voluntary demand cuts that become mandatory by Friday. It starts with price spikes that punish anyone who keeps running full tilt. Rationing doesn't arrive with a drum. It arrives with an invoice. And here's another hidden concept that matters: line pack. Pipelines carry gas, yes, but they also store it by pressure. The higher the pressure, the more gas is sitting inside the network like a compressed buffer. When storage and line pack shrink together, the system loses its shock absorbers. Then a normal cold evening can behave like an emergency. Here's the best analogy. Imagine 2 cars both showing half a tank. One car has a wide fuel line, the other has a pinched fuel line. Same level, different ability to deliver power when you slam the accelerator. That's storage in winter. The percentage tells you how much. It doesn't tell you how fast. And how fast is what keeps industry alive when the temperature drops tonight. Now let's connect that to silver. Silver doesn't become industrial grade by magic. It becomes industrial grade through heat, chemistry, electricity, and time. Refining and recycling are energy intensive, not turn the thermostat down intensive. We're talking high temperature furnaces, smelting, electrolysis, continuous processing, controlled atmospheres, systems designed to run steady. Let me show you the pipeline inside the refinery, because this is where the story becomes real. Step 1, you melt feedstock, scrap, concentrates, industrial residues into a controlled molten stream. Step 2, you separate impurities. Some of that is thermal, some is chemical, some is electrochemical. Step 3, you produce high purity silver, often in forms industry can actually use: grain, powder, anodes, wire stock, plated inputs. This is not optional. A solar manufacturer doesn't want almost silver. They want spec. They want consistency. They want delivery. If a refinery loses gas suddenly, you don't just pause the process. Metal can solidify in crucibles. Lines can clog. Equipment can crack. Restarting isn't a switch, it's a surgery. That's why the moment rationing becomes plausible, refineries don't wait to be cut. They throttle first. They idle first. They protect the plant. And that is how a gas number becomes a silver shock. Germany is not just a consumer. It's a processing hub. Major precious metals groups operate there, handling recycling, refining, and fabrication across multiple metals: gold, silver, platinum group metals, the whole stack. Some of these firms describe themselves as global leaders in precious metals, refining, and recycling. That matters because in the real world, refining capacity is a gatekeeper. If the gate slows, the world queues. Here's the mechanism that hits markets before the headlines do: allocation. The moment gas gets tight, the system starts choosing winners and losers, not by opinion, by contract type. Some industrial users are interruptible, meaning they get cheaper rates because they agree to be cut first. Others are protected or priority because society can't function without them. Refineries typically sit in the wrong category, especially compared to hospitals, district heating, and essential food supply chains. And this is where the word non-essential becomes dangerous. A refinery doesn't look essential until you list what it feeds: electrical contacts, medical components, chemical catalysts, electronics, high reliability solder, solar supply chains. The refinery is upstream. Upstream crises look invisible until downstream shelves go empty. And Germany isn't isolated. When multiple European storage clusters drift lower at the same time, the system becomes brittle. One cold week, one infrastructure outage, one shipping disruption for LNG. Suddenly the market goes from stable to triage. Europe can be comfortable and still be fragile. Those are not opposites. There's another layer here that matters. Europe did not start 2026 from a position of strength. Market analysis across Europe has noted storage entered the year meaningfully lower than the previous year. Less buffer, less margin, more sensitivity to weather. That's why a German problem doesn't stay German. A weaker European starting point means the whole system has less room for error. Let me be precise. Halted doesn't always mean a dramatic, government-ordered blackout. Sometimes it looks boring. A notice, a maintenance extension, a temporary idle, a shift reduction. But if enough refineries do that simultaneously, the effect is identical to a shutdown. Refined output drops, lead times explode, and the physical market tightens overnight. Here's the key. Mining and refining are different bottlenecks. A mine can produce concentrate, but concentrate is not an iPhone part. It is not a solar paste input. It is not a bar that meets spec. Refining is the conversion step from material exists to material is usable. So when refining slows in a central hub, the impact isn't just local. It propagates outward like a wave. You've heard estimates flying around. A European throttling could remove 15 to 20% of global refined silver availability overnight. Treat that as a stress test number, not a gospel number. The exact percentage depends on what counts as refined, what counts as available, and how quickly other hubs can backfill. But the direction is what matters. A synchronized European slowdown can be large enough to move physical premiums without warning. Futures can trade 1 billion ounces in a day with keystrokes, but the physical world has to melt, purify, cast, stamp, ship. If refining slows, the paper market can pretend nothing happened until the day someone actually asks for delivery on schedule. That's when the illusion meets the warehouse door. Watch how a refinery throttle expresses itself. First you see longer lead times. Then you see allocation. We can only ship you X. Then premiums widen, because the market is bidding for the few units that can move now. Then spreads distort. Nearby delivery becomes expensive relative to later months. And only after that does the headline price adjust, because the paper market is the last place the shortage becomes undeniable. Industrial demand doesn't negotiate with ideology. It doesn't care about narratives. It cares about parts. If procurement hears energy rationing, they don't wait for a press conference. They pull orders forward, they increase safety stock, they lock contracts. Because for a factory, running out of silver isn't expensive. What triggers stoppage? It's penalties. It's broken delivery promises. It's lost customers. And this is happening in a silver market that many analysts already describe as structurally tight. Multi-year deficits, strong industrial demand, and a supply chain that has become less redundant. When you're running a system with no slack, any disruption looks bigger. A 10% hiccup behaves like a 20% shock because there's no warehouse mountain waiting to save you. This is why I called it the invisible collapse, because when a refinery idles, nothing explodes on camera. But the market loses something precious: time. Every day of reduced throughput stacks into a backlog, and backlog is how shortages announce themselves in the real world. Here's the concept to remember. The last part empties differently than the first part. As inventories decline, withdrawal capacity declines. Storage has minimum operating constraints. Deliverability falls. The system becomes less flexible exactly when winter volatility demands flexibility. So a number like 20% becomes a symbol, not because it's magic, because below certain ranges, you can't depend on the network to respond to spikes. And Dunkelflaut is the perfect trap. It arrives quietly. A week of weak wind, a week of gray sky. Temperatures drop, demand rises, renewables underperform. So gas plants run harder, not as a luxury, but as grid insurance. Every hour those turbines don't spin, gas becomes the stabilizer. And every hour gas stabilizes the grid, storage drains faster. People ask, can't Germany just import more LNG? Yes, up to the limits of terminals, shipping schedules, and global competition. But LNG doesn't teleport. It's a physical supply chain with weather risk, port congestion, cargo competition, and price volatility. When a continent needs emergency molecules, the molecules go to the highest bidder first. And that sets up the same dynamic again. Households get protected, industry gets priced out. The policy logic is straightforward. In an emergency phase, the goal is to secure vital demand, protect households and critical institutions, and minimize consequential damage. In broad brush terms, supply to industry is curtailed first. So if you are running a gas-hungry, high-temperature process that is not classed as protected, you are the lever the state pulls. Let me translate Germany's emergency gas plan into human language, because this is where the silver halt becomes plausible. Early warning means the system sees concrete signs something could break. Operators coordinate daily. No one is forced off yet, but everyone prepares. Alert means there's disruption or unusually high demand, but the market is still expected to cope using market tools. Imports, efficiency, fuel switching, voluntary cuts, higher prices. It's pressure, not panic. Emergency means market tools failed, supply is insufficient. Now the state intervenes, and the network regulator becomes the traffic controller. In that phase, gas is allocated with special protection for households and vital institutions, and industry is curtailed to minimize wider damage. So the real question for silver is not, will Germany ever hit zero? The real question is, how close is Germany to the moment it must choose who stays online? Here's the mental trap that destroys analysts every winter, treating a storage percentage like a phone battery. 40% does not mean 40% of the winter left. It means 40% of working gas volume remains, and the ability to withdraw that gas depends on pressure, facility design, and the network's ability to keep flow stable at peak demand. Underground storage doesn't empty in a straight line. Withdrawal capability usually declines as inventories decline. Operators call it a ratchet. Engineers call it physics. So the last chunk of gas is not a smooth glide to zero. It's a narrowing door. That's why the same storage level can look calm on paper and terrifying in a control room, because the control room is watching how fast the door is narrowing. Silver refining ends up first in line for two reasons. One, it's energy intensive and often flexible in the eyes of policymakers, because the end user is far away. Two, a refinery can be told to cut without an immediate public backlash. People don't riot because a cathode sheet shipment is delayed. They riot when their homes go cold. So the political incentives are clear. But second-order damage is where the real cost appears. A delayed refinery output means delayed fabrication. Delayed fabrication means delayed components. Delayed components mean factories miss delivery windows. And once you miss a delivery window in industrial supply chains, you don't just lose money. You lose trust. That is why industrial buyers hoard. Hoarding is rational when the penalty for shortage is existential. Let's go inside the moment this turns real. It's 3 a.m. The plant is running hot. Not warm, hot. The kind of heat that lives in the walls and in the floor. A furnace is holding temperature. A chemical bath is in spec. A batch is mid-cycle. You don't pause that like a podcast. Then the supervisor gets a call from the utility. Be ready to reduce load. Not shut down. Reduce load. But the supervisor knows what that really means. Silver refining isn't a dimmer switch. If you reduce too fast, you damage equipment. If you wait too long, you get cut mid-process. So they do what heavy industry always does when it smells rationing. They shut down on their own terms. They ramp down in a controlled way. They protect the furnaces. They secure the melt. They preserve the plant. They delay casting. They delay quality checks. They delay stamping. They delay shipping. And the output that was supposed to leave this week, it becomes next week, then the week after, then allocation only. Now imagine 5 plants making the same decision in the same week. Nothing breaks on camera, but the market starts hearing the same sentence from every distributor. We can't promise delivery at spot. Off-ramps exist, mild weather, LNG, demand cuts, but you can't build a silver forecast on luck. Model the bad week, now. So I want you to stop staring at the daily candle and start watching the plumbing. Watch storage trajectories, watch withdrawal rates, watch hub volatility, watch regulator language, watch refinery, maintenance, watch shipping chatter, because the physical market speaks in delays, not in headlines. Let's map it cleanly. Base case, mild weather continues, storage drains slowly, industry trims around the edges, silver tightens slightly, premiums widen in pockets. Stress case, a cold snap hits, renewables underperform, gas burn spikes, industrial curtailment becomes real, refiners throttle, lead times jump, physical premiums detach from spot. Emergency case, multiple shocks stack, cold plus outage plus shipping disruption. The system enters triage, industry gets cut hard, refining output drops sharply. The paper price struggles to keep up with the real-world scramble for metal. Picture the scene. It's still dark. The air bites. A plant manager is staring at a screen that doesn't show silver. It shows pressure, flow, volume. And the message is simple. You may not have enough fuel to finish the week. So they call procurement, they call logistics, they call the head office, and somewhere else, quietly, someone else calls the bullion desk and says, lock what you can, now. This is why the price reaction can come late, because the market doesn't price what it can't see. And a refinery idling is not a screaming headline until shortages show up where people can touch them. Coins, bars, industrial feedstock, delivery schedules, fabrication delays, then the story catches fire. I'm not telling you what to buy. I'm giving you a framework. When energy becomes scarce, the first casualty is processing. When processing slows, refined metal tightens. When refined metal tightens, premiums detach from spot. And when premiums detach, the real price starts migrating to wherever supply is still available. One more thing, and this is just a survival rule. Do not confuse a shortage narrative with a permission slip to gamble. Shortages can be volatile. They can whip the price around while the physical market stays tight. So if you use leverage, you're not betting on silver. You're betting you can survive the shakeout. Most people can't. Stay strategic, stay patient, stay alive. Here's your watch list for the next 30 days. Germany storage trajectory on the transparency dashboards. The regulator's language, stable versus tight versus emergency. Weather patterns, windless cold snaps, prolonged freezes. European hub pricing, volatility, and sudden spikes. Refinery updates, production guidance, maintenance, delivery delays. Physical market chatter, allocation, back orders, extended lead times. Because the 41% redline is not a meme. It's the point where Europe stops acting like this is a normal winter and starts acting like a survival problem. And when a continent starts acting like survival, markets follow.